OpenAI just broke the game of hide and seek. For many years, AI researchers have been trying to create intelligent machines by studying and replicating the structure and functionality of the human brain. The latest research from OpenAI intended to look into the possibility of AI agents learning sophisticated and real-world relevant techniques without any suggestions from the researchers. They simply put agents in a simple game of hide and seek, where they used objects in unexpected ways to achieve their goals. So in this video, we will take a look at how OpenAI tried to train AI agents to play hide and seek and why they were completely shocked. Make sure to watch the video until the end to know how these types of self-taught AI agents could be helpful in the real world as well. Gaming has always been used to evaluate the advancement of AI. This is why researchers are trying their best to unite AI and games to help machines learn from gaming data. Their goal is to improve AI's ability of self-learning, which could then be applied to applications in the real world. Games like chess and solitaire have helped us to show how intelligent computer algorithms are getting by pitting them against top human players. Each victory of machines has helped algorithms to get more competent and more efficient. OpenAI, one of the leading AI research labs, recently taught a pack of intelligent artificial agents, or bots, to play hide and seek. The idea is familiar to anyone who has ever played the game in real life. In short, it's kind of a scaled down arms race. The AI agents have to play a straightforward version of the game where the hiders get a little time at the start to set up a hiding place. They get points when they successfully hid themselves, and seekers get points whenever the hiders are in their field of view. They can move and lock the objects like blocks, walls, and ramps around the field to prevent other teams from manipulating. This detail was probably added to simplify the environment for the agents, or the game could turn into an endless competition of hiders and seekers manipulating objects. And when your opponent adopts a strategy that works, you have to abandon what you were doing before and find a new plan to win. The system uses reinforcement learning, an AI technique that is especially popular in research projects. Their main purpose was to observe how competition between hiders and seekers would drive the agents to look for digital tools. During the first stages, a team of 2 seekers and 2 hiders were released in a very simple environment. At first, AI bots didn't know what to do. It was a random chase between hiders and seekers. They failed to manifest any form of intelligent behavior. But after many games, both hiders and seekers developed some very interesting tactics, both individually and collectively. After many games, hiders learned to move boxes around them, to lock the door, and to create a safe environment for themselves in a room to prevent seekers from finding them. But after that, seekers learned to move the ramp around them to climb the walls and discover the hiders. As a result, hiders learned to move the ramp inside with them to prevent the seekers to even use it. Agents learned all these things after 50 million episodes. After that, AI researchers introduced a more open environment to agents. There weren't any secret rooms, and the number of variety of objects were increased to add complexity. The number of agents was also increased to increase their sense of cooperation and teamwork. It started again with AI agents moving randomly, but after millions of games, they started manifesting exciting behavior. As there weren't any secret or closed rooms, the hiders learned to create their own hideouts by placing objects around them and locking themselves. And then seekers learned to use ramps to jump over the objects and find hiders. After hundreds of millions of games, the hiders finally learned to lock the ramps before creating their hideouts, so seekers won't be able to move those ramps to find them. But after 100 million matches, the seekers developed a new tactic. They used an unlocked box beside the ramp. They glided next to the hideout and discovered hiders. Finally, after 80 million episodes, the hiders learned to lock all the objects before hiding them inside their hideout, so in this way, seekers won't have any way to discover them. They did it in a perfectly coordinated way and made sure that they had locked everything before hiding. During the game, agents found some exciting ways to exploit the system to achieve its goal. Just like in one case, the hiders threw ramps outside the game, and seekers managed to find a glitch in the system to fly over the playing field and find hiders. The fascinating thing about the behavior developed by the hide and seek agents is that they evolved organically. In almost all cases, the performance of the emergent behavior was superior to those learned by intrinsic motivations. As it is difficult for humans to direct every aspect of AI, we can't control its abilities by parameterizing and controlling its interactions with the environment. There are so many factors that behaviors designed by us won't be able to produce the sophistication that's necessary for these agents to take their place in everyday life. Supervised learning methods remain the dominant paradigm in AI. it is relatively unpractical to apply it to many real-world situations. This hide-and-seek experiment was absolutely fascinating and demonstrated the potential of a multi-agent competitive environment as a catalyzer for learning. Many techniques can be extrapolated in which learning by competition seems like a more viable alternative than supervised training. Learning by competition is one of the emerging prototypes in AI that resembles how our knowledge evolves as a human. We develop new knowledge by exploring our surroundings and interacting with other people when we are babies. We sometimes interact in a collaborative fashion, sometimes in a competitive model. AI will also be able to learn to interconnect with an environment in which agents are linking with physical objects in a relatively unknown environment. In such an environment, it is more natural that agents constantly compete with each other, developing new organic knowledge. The OpenAI researchers posit that self-learning agents are the way forward in many circumstances where other methods are too slow or structured. They can acquire and renew knowledge on their own over time, without the need for complex coding. Such type of system first seeks to engage with its users, or the surrounding environment, and then observes the changes generated by its activities. Researchers at OpenAI concluded, these results inspire confidence that in a more open-ended and diverse environment, multi-agent dynamics could lead to an extremely complex and human-relevant behavior. We can conclude from such projects that this is the new light in which we can view artificial intelligence. For many years, the human brain has been used as an example to follow when creating intelligent systems. But now, maybe looking at a less complicated but efficient mechanism of evolution could help us to discover new ways to develop systems that can effectively solve problems. And who knows, maybe it can help us solve the mystery of creating human-like intelligence. But the question arises if AI should learn from us, or if we should let them continue to teach themselves. Self-learning without human supervision could teach AI more efficiently and creatively, but this could create algorithms much more appropriate to the task that don't need human collaboration or help. Is Elon Musk right that AI will be able to beat humans at everything by the end of 2030?
What's going to happen is robots will be able to do everything better than us. I'm including, all of us,
Garry Kasparov, who is considered the greatest chess player in history, faced a chess-playing computer. Despite beating the system, he said, "I could feel, I could smell a new kind of intelligence across the table." And the next year, he was beaten by the system. It was the first time when a world champion failed in front of an AI. In 2017, a self-taught computer beat the world's best human players in the strategy game Go. Google developed the DeepMind system to beat the Go world champion KG to claim the title of the world's best player. And that too without any input from the humans. DeepMind retired AlphaGo after the match with KG, while continuing AI research in other areas. The self-taught AlphaGo Zero achieved an 100-0 victory against the early competitive version of AlphaGo. Some experts, like the computer scientist Mark Toussaint at the University of Stuttgart in Germany, warned that these kinds of AI projects still haven't answered us a major question. Does such work aim to mimic evolution's ability to train or evolve agents for one particular niche? Or does it aim to mimic human and higher animals' ability for on-site problem solving, generalizing, and dealing with never experienced situations and learning? Researchers should keep in mind these questions before conducting such experiments, because on the one hand, this game is a powerful technique that can produce advanced behavior from a basic start, but on the other hand, it can produce unexpected and sometimes undesired behavior from a simple training point. The side effect of learning by competition is that agents can develop behaviors that are unexpected. Imagine that you are training an AI agent to master a specific game, and suddenly, it finds a strategy that has never been tested before. Of course it will scare you. The machine is learning what you don't even know. No doubt, as AI gets more innovative, we are all in for more surprises. So this brings our video to an end. What do you guys think about AI? No doubt, AI technology is getting better rapidly. But are we on the verge of singularity? Does it scare you? Should we admit that AI is better than us at a whole raft of things, from games to problem solving? Should we supervise AI or let it discover new things on its own? Or should we stop here? Share your opinions in the comment section below, as we have always loved to read your comments. And as always, thank you for watching.